So today we're gonna discuss this question from Lead Coding Challenge. Problem 9. Find the town judge. In this problem it is given that in a town there are n people labeled from 1 to n. There's a rumor that one of these people is secretly the town judge. Okay. If the town judge exists, if there is a town judge in the town, then the town judge trusts nobody. This is the first condition. Everybody except the town judge trusts the town judge. And there is exactly one person that satisfies the properties 1 and 2. So this condition means that every person in the town must trust the town judge, and a town judge should be one in the town, and he should not trust anybody. So you are given a trust array which has a pair of A and B such that which represent that the person A trusts the person B. So if there exists a town judge, like if you identified it, return the label or return its number, otherwise return -1. So you can use a sort of directed graph to find out the answer. I have drawn some examples. Okay, so if the first array or the first value in the array states that 1 trusts 2, and because there are 2 people in the town and 1 trusts 2 and 2 doesn't trust 1, so it means that 2 is the town judge. Why? Because he doesn't trust anybody, and except him there is only one person in the town and he trusts the town judge. In this case there are 3 people, and because 1 and 3 both trust the person 2 and he doesn't trust anybody, that's why 2 is a town judge. Now look at this example. Though 1 and 3 trust the person 2, but 2 also trust 1. So that's why this cannot be a town judge, because the town judge, though everybody except the town, like this person, like trust this person 2, but 2 also trust 1. That's why he can't be a town judge. In this, as you can see, 2 trust 3, 1 also trust 3, 1 also trust 2, but 3 trust 1. Now as you can see there are 2 persons and both of them trust 3, but 3 also trust 1. That's why like there is no town judge. Okay, but what happened if this is not there? Now as you can see, 1 trust 2 and 3, and 2 trust only 3. As like this can also be there such that 2 trust 1 also. But there is a case such that 3 is trusted by both of them. So the logic can be, because every person trusts this person, the in degree or the number of arrows towards this node should be equal to n-1, the total number of people -1. Everyone should trust this person. So n-1 in degree should be there towards this node. But if, how can we give a penalty to it? If this person trust anybody, so that in this case there is an in degree of 2, but he also trusts someone else, so we can subtract the in degree minus the out degree, which is equal to 1, and then in the final array we can maintain how many in degree and out degree are there for every node. If the in degree total is equal to n-1, which means every person trust this person and this person do not trust anybody else, because if he trusts anybody else there would be an out degree and it will decrease the total number of in degree in this node such that the count will decrease and we have to return -1. I hope you understand the logic. Now we can directly code this out. So the code is very simple. You have to make a vector of array of size n+1. You can make it dp n+1 and initialize everything with 0. Then iterate over this trust array n for every in degree is I of 1, because the tuplet of pair, or like the pair, for the first value represent the person A and the second value represent the person B. So if A trusts B, there is an arrow from A to B. And for the in degree, how many in degree at B are there? We have to increase for B, and for out degree we have to subtract here. Now what we'll do is we'll iterate over from 1 to n, and if we found that if dp of I is equal to n minus 1, then this we are just have to return I, which is the town judge. Else if we come out of this loop, we have to return minus 1. So let's run this code. Is given the right answer. Let's submit this, and it is accepted. I hope you understand the logic of how I made this graph and how I counted the number of in degree and out degree. If you still have any doubts, please mention down in the comment box. I have a lot of videos on LeetCode and all other programming platforms, so go check them out. I'm also making a series on the DP educational round from AdCoder, so I'm also updating that. So go check them out also. Thank you for watching this video, and see you in the next one. Bye.